The field of astronomy stands at the edge of a profound moment. The James Webb Space Telescope, with its unparalleled ability to peer into the furthest depths of our universe, has delivered an image that is not only stunning but scientifically groundbreaking. Yet this ultra-deep image has proven to be much more than the discovery of ancient galaxies. It may, in fact, challenge some of the most fundamental principles of our understanding of cosmic evolution. In this video, we will explore how these observations may suggest errors in our current models, delve into the unexpected findings that have emerged, and show how this discovery underscores the iterative and ever-evolving nature of science. What if the universe is far stranger than we ever imagined? The James Webb Space Telescope serves as humanity's most advanced tool for peering into the cosmos. With its advanced infrared capabilities, JWST can penetrate dust clouds, observe faint light from ancient stars, and reach farther into the depths of space and time than any of its predecessors. Astronomers launched the telescope with high hopes that it would refine our understanding of the universe's infancy and the processes that led to its development. The standard cosmological model, built upon decades of observations and theories, postulates that galaxies formed in a relatively gradual manner following the cooling of the early universe. The JWST was expected to fill gaps in our knowledge, confirming that the universe's initial structures matched predictions derived from these models. The idea was simple. By looking deeper into the universe, the JWST would help us map a timeline of cosmic history with greater precision. It would provide the clearest view of distant galaxies, illuminating the period shortly after the Big Bang. Expectations were anchored to decades of theoretical modeling. But what happens when observations veer dramatically from predictions? Scientists recently turned JWST's extraordinary gaze toward a region of space to generate an ultra-deep field image, a collection of data that captures some of the oldest light in existence. Success seemed guaranteed, as prior missions like the Hubble Space Telescope's deep field images had already demonstrated the immense value of such surveys. But what astronomers found left them both amazed and unsettled. The image revealed unusually mature and abundant galaxies, some estimated to have formed only a few 100 million years after the Big Bang. According to prevailing theories, these galaxies should still be in their infancy at such a distance in time. Instead, they appeared far older, more evolved, and more organized than expected. Even more striking was the sheer number of galaxies in the image. These weren't isolated outliers. The picture depicted an abundance of light-emitting sources that collectively painted a picture inconsistent with estimates derived from standard cosmological models. The age, structure, and sheer quantity of these galaxies raised a simple but disquieting question. Have we misunderstood the timeline of early galaxy formation? These findings chip away at some of the cornerstones of modern cosmology. Central to our understanding has been the belief that galaxies require significant time to accumulate mass and form the complex structures we observe today, like dense cores and spiral arms. Fundamental cosmology posits that galaxies are the result of matter clumping together under the force of gravity over time. Stars ignite within these structures, later giving rise to planets and eventually life. It was assumed that the cosmic dawn of galaxies occurred in a relatively steady sequence, beginning approximately 400 million years after the Big Bang. However, the JWST's ultra-deep image suggests a much faster and more chaotic evolution. Galaxies appear fully formed, where scientists expected to find immature clumps of matter. Could this mean that the formation of stars and galaxies occurs more rapidly under certain conditions than we anticipated? Or is it possible that our interpretation of cosmic light and distance, often central to estimating age, needs to be revised? Faced with these surprising findings, scientists are developing a number of potential explanations. Hypothesis 1 revolves around the idea that galactic evolution occurs more efficiently than previously modeled. If galaxies can collect matter and consolidate into organized structures rapidly, it would explain why these newly discovered systems appear unexpectedly mature. Another possibility pertains to errors in how we interpret light from distant galaxies. Astronomers rely on redshift, the lengthening of light waves caused by the expansion of the universe, to estimate distances and, by proxy, time since the Big Bang. If our understanding of redshifted light is flawed, we could be misinterpreting the cosmic timeline. Could there be factors influencing light in ways science hasn't yet accounted for? Additionally, this discovery begs a larger question about the fabric of the cosmos itself. Cosmological constants such as dark matter, dark energy, and the rate of the universe's expansion underlie standard models. Could this ultra-deep image signal that one or more of these constants might require revision? Even more tantalizing is the idea that some completely unknown mechanism could be at play, something not yet included in our frameworks of galaxy formation. At first glance, the idea of an error in our understanding of the universe might seem unsettling. However, anomalies like those uncovered by the JWST occupy a special place in the history of science. They force academics and researchers to refine their models, pose new hypotheses, and ultimately draw closer to the truth. The classic image of science as a collection of unchanging facts is far from reality. In practice, science advances by questioning and revising assumptions. Consider the revolutionary impact of the Copernican model, which overturned centuries of geocentric belief, or the role of quantum mechanics in redefining 20th century physics. JWST's ultra-deep image raises questions, not barriers. As one researcher noted, anomalies are not failures, they are opportunities. Each challenge to the status quo represents a chance to ask, what did we overlook? This discovery reminds us that the pursuit of knowledge is an ever-evolving process where mysteries inspire new waves of exploration. Predictably, the release of this data triggered a surge of activity across the academic world. Astronomers and physicists rushed to generate papers, debates, and workshops to make sense of the findings. Some suggested modifications to existing models, while others proposed completely new ways of interpreting early universe observations. A portion of the community remains cautious, urging patience as further observations accumulate. Others are eager to consider implications that reach beyond galaxy formation, pointing to the possibility of recalibrating the broader timeline of solar and stellar evolution. Among these competing voices, one sentiment stands out: excitement. Scientific communities thrive in moments of disruption, finding momentum in the questions such discoveries provoke. This moment in astronomy is no exception. As we stand on this fascinating frontier, it is clear that the JWST is only beginning its exploration. The anomalies observed in its ultra-deep image necessitate further study, including follow-up observations that target similar regions of space. Astronomers plan to leverage its next cycle of observations to refine data, look for patterns, and verify whether the findings are consistent across multiple regions. Additionally, ground-based telescopes may play a supporting role in confirming the redshifts uncovered by JWST's sensitive instruments. This is also a moment for collaboration across disciplines. Astronomers, physicists, data scientists, and cosmologists will need to work together, sharing insights that sharpen our understanding of galaxy formation, large-scale structure assembly, and the evolution of stars. In the long term, adjustments to theoretical models may ripple through various fields of study, from planetary science to the search for extraterrestrial life. Understanding the birth and growth of galaxies has direct implications for understanding how planets and ultimately habitable worlds form. As we reflect on this pivotal discovery, it's impossible not to marvel at the relentless curiosity that drives humanity to unpack the mysteries of the universe. From the Big Bang to the formation of the first galaxies, our understanding has grown with each leap in technology and ingenuity. Now, the JWST urges us to once again question what we think we know. Its ultra-deep image is more than just a picture. It's a reminder of science's iterative nature and the profound allure of the unknown. For professionals in astronomy and astrophysics, this discovery offers a watershed moment, an opportunity to reshape how we think about the cosmos. Every breakthrough begins with a question, and the mysteries revealed by JWST are poised to inspire decades of answers. As you watch the cosmos unfold through the extraordinary eye of the JWST, remember, the deeper we gaze, the more boundless the universe becomes.